Hello students and good morning. So today we will do this chapter, that is integration by parts, and in the last online class also we were doing the same topic, that is integration by parts. So that means today is your continuation class of this chapter. So same exercise 7, page number 380, 4 mark section from the book Higher Mathematics for Class 12 by SND. So let's do this question number 6. And in the last online class we finished up to question number 5. So let's do this question number 6. That is, you have to evaluate this integral. Okay. That is integration of within bracket. It is cos inverse x plus log x bracket close. Then dx is there. Dx means with respect to x. So let us first write I is equal to integration of within bracket. This is cos inverse x plus log x bracket close dx. So now how will you integrate it? So this is from the chapter integration by parts. So first of all you have to separate this integration. Okay. So or I is equal to, this is integration of cos inverse x dx plus integration of, this is log x dx. Okay, now this is only integration of cos inverse x dx. So if you have integration of only cos inverse x dx, in this case also you have to do integration by parts. Actually there are two functions here. One is cos inverse x, that is your inverse circular function, and the other one is 1. 1 means x to the power 0. You can take it as algebraic function. Similarly, this is also integration of only one function is there, log x dx. So if there is only log x dx, in this case also you have to use integration by parts. Actually there are two functions here also. One is log x and the other one is 1. 1 means x to the power 0. You can take it as algebraic function. Is that clear? So now for these two functions you have to use integration by parts using the word let or ilet. I already told you about that, how to use integration by parts. This is cos inverse x, that is I, and there is 1, that is x to the power 0, that is algebraic function, that is a. So which letter comes first in the word ilet or let? That means I, that is inverse circular function I letter comes first in the word let or ilet, isn't it? So this cos inverse x, it comes in the front. So use integration by parts for this first function. Okay. So or this is I is equal to cos inverse x is taken outside, integral sign dx, then minus sign is there, integration of second bracket dy dx of, this is cos inverse x. Okay. Then integration of dx second bracket close dx. So this is integration by parts for this first function. Similarly you can use integration by parts for this second function also. Let us write it here. Actually this is the continuation line. Okay, so there is only log x is here. If there is only log x, in this case also you have to use integration by parts. Actually there are two functions, log x and 1. Log x is logarithmic function, that is L, and 1 you can take it as x to the power 0, which is algebraic function. So L and A. L means logarithmic function and A means algebraic function. So which letter comes first in the word let or ilet? That is L comes first, isn't it? So log x is the first function and algebraic function is the second function. So you can take it outside. Use integration by parts now. So it is log x integration of dx minus second bracket minus integration of second bracket is opened dy dx of, this is log x, right? Then integration of dx second bracket closed, this is dx. So I think you have understood it. So for both these functions you have to use integration by parts. Okay, so or now this is I is equal to, now you first integrate. What is integral sign dx? This is x cos inverse x minus integration of What is d by dx of cos inverse x? You know the differentiation of cos inverse x with respect to x. What is it? It is minus 1 upon root over 1 minus x square. It is, what is the differentiation of cos inverse x with respect to x? Minus 1 upon root over 1 minus x square. Then what is integral sine dx? That is your x. Then you have to write down this dx, okay? Plus, again here, what is integral sine dx? That is your x. Then log x is kept as it is, right? So minus integration of, what is d by dx of log x? It is 1 by x. It is 1 by x into, what is integral sine dx? X, then what do we write? Dx, okay? So here this xx will be cancelled. So in the next step we have, or I is equal to, which is the first function? X cos inverse x. It is x cos inverse x. So minus into minus, plus integration of, next it is x upon root under 1 minus x square. X upon root over 1 minus x square dx. Is that clear? Next plus x log x plus x log x, then minus integral sign. This is xx will be cancelled. That is your integration of dx. Minus integration of dx. So I think you have understood it, okay? So or I is equal to x cos inverse x plus, let us write it as I1 because you have to integrate this integral, right? So integration of x dx divided by root under 1 minus x square, it is taken as I1. Then plus x log x minus, what is integral sine dx? That is your x. Then what do you write? Plus c. So after integration you have to write c as a constant of integration. I already told you about it. In case of indefinite integration, so after you integrate all the function, you have to write constant of integration, that is c, as the last term, okay? So if you don't write this constant c, then 1 mark will be deducted in your examination, okay? So what is I1 here? So let I1 is equal to integral sine x dx divided by root over 1 minus x square. So you know how to integrate it. You can use the method of substitution here. Within square root there is 1 minus x square and in the numerator there is x. So within square root there is 1 minus x square. If you differentiate the term, if you differentiate 1 minus x square with respect to x, you are getting minus 2x. That means you are getting x, isn't it? So let us assume 1 minus x square as z square, because 1 minus x square is on the square root and the square root is in the denominator. If the expression is on the square root and if the square root is in the denominator, you can assume this 1 minus x square as z square. I already told you about this one, isn't it? So let us assume, let z square is equal to 1 minus x square. So this is the method of substitution. Now which is the new variable? New variable is z. Now you can differentiate both the sides with respect to x. So differentiating both the sides with respect to x. So what do we get? What is the differentiation of z square with respect to x? It is, you know that 2z into dz by dx, which is equal to, for 1 it is 0, you don't have to write it. For minus x square it is minus 2x. So here this 2 gets cancels, or z dz is equal to minus x dx. So I think you have understood it, okay? So what is the value for x dx? X dx is equal to minus z dz, because you have to get the value for x dx. Is that clear? So what is I1 now? So I1 is equal to integration of, what is x dx? Minus z dz divided by, what is square root of z square? That is your z, okay? So here z gets cancels. or what is I1 now? So I1 is equal to minus integral sine dz. Is that understood now? So next, what is I1? Or I1 is equal to, this is minus z. Okay, so minus z, then plus c. Now we can put the value for z. What is the value for z now? So z is equal to, since z square is equal to 1 minus x square, what is the value for z? It is root under 1 minus x square, or I1 is equal to minus root over, it is, if z square is equal to 1 minus x square, what is the value for z? It is root under 1 minus x square. Then you can write plus c. Is that clear? Now you can put this value of I1 in I, because you have to get the value for I, isn't it? So let us write I here now. So I is equal to, which is the first term? X cos inverse x, x cos inverse x, okay, plus I1, which is plus I1 here, plus and minus minus, it is root over 1 minus x square. You don't have to write this plus c. So in the last term you can write c as constant of integration, okay. So don't write down this c out here, okay. So plus x log x, plus x log x, then what do you write? Minus x. Then you can write plus c. Only one constant of integration, that is c, will be included in the answer, okay. You don't have to write down two c's out there, okay. Only one c will do, okay. So you have to add only one constant of integration. So what is the final answer? That is I is equal to x cos inverse x minus root over 1 minus x square, that is the value for I1, plus x log x, then minus x plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 7. So let us evaluate this integration. The question is integration of within bracket log root over x whole square dx. So let us simplify, first simplify this expression, okay. So let us write again here I is equal to integration of, this is log root over x whole square dx. So let us simplify it first. What is root over x? How can you write down this root over x? Root over x can be written as x to the power half, okay. So or I is equal to, this is integration of within bracket log x to the power half whole square, then what do you write? Dx, okay. Now in this case you should know the properties of logarithm. You know these properties of logarithm. Now log, if there is log x to the power n, if there is log x to the power n, that is power n is for only x. So you can use properties of logarithm here, that is n comes in the front, that is it can be written as n log x, that is it is n log x, right? Similarly this half comes in the front of log x, okay. Or I is equal to integration of, this one is half comes in the front but it is within bracket, so it is half, this is log x whole square dx. Is that clear? Next, or I is equal to, you can simplify it further, integration of half whole square is 1/4, then it is log x whole square dx. Next, 1/4 is constant, you can take it outside, integration sign. So I is equal to 1/4 integration of, this is log x whole square dx. So this question is very, very important. You can mark it, okay. So now you can use integration by parts here. Log x whole square is the only logarithmic function out here. But there are two functions here, log x whole square is log x whole square and 1. So actually 1 is x to the power 0. That is your algebraic function. So log x whole square is logarithmic function, that is L, and x to the power 0 is algebraic function, that is A. So among these L and A, which letter comes first in the word liet? I already told you about that, liet or ilet, isn't it? So this L comes first in the word liet. So this log x whole square will be the first function. So let us use integration by parts in this case, okay? So or I is equal to 1/4 is constant out here, you have to write it. And within third bracket, let us use by parts here. So log x whole square is the first function, isn't it? So it is taken outside, integral sign, and it is integration of what? Dx, you know integration by parts. Dx minus integration of second bracket. This is your dy dx of what? It is log x whole square, right? That is dy dx of the first function. That is, you have to take the differentiation of the first function with respect to x. Then integration of the second function. That is integration of dx. Second bracket closed. Then what do we write? Dx. Is that clear? Then third bracket is closed. And this is the properties of logarithm. Okay? So next, or I is equal to 1/4 within third bracket. Now let us use integration first. What is integral sign dx? That is your x. That is your x, right? Integral sign dx is x. Then it is log x whole square minus integration of, what is dy dx of log x whole square? You can take it as x to the power n. What is the differentiation of x to the power n? N into x to the power n minus 1. So it is twice comes in the front, and this is log x whole to the power 2 minus 1. That is 2 minus 1 is 1. So this is log x whole to the power 1. If the power is 1, you don't have to write it. So it is log x. Again, differentiate the term which is assumed as x. That is log x is assumed as x. What is this differentiation? It is 1 upon x into, what is integral sign dx? That is your x. Then what do you write? Dx. Third bracket is closed, right? So here xx gets cancels. So now let us open this bracket now. Now multiply by 1/4. So it is 1/4 x into log x whole square minus 1/4 into 2. 2 1s are 2, 2 2s are 4. This is half. This is half integration of, this is log x dx. This is log x dx. Okay? So now again this is integration of log x dx. Here also you have to use integration by parts. This is the only function here, log x. Only one function is there, but in this case for logarithm and inverse circular function you have to use integration by parts. I already told you about this one, right? So actually there is log x and 1 is there. 1 is x to the power 0. That is log x is logarithmic function and x to the power 0 is algebraic function. This is L and x to the power 0 is A, algebraic function. So in the word liet or ilet, L comes first. So this log x is the first function. So use integration by parts for this integration. So I is equal to 1/4 x log x whole square minus half, now within third bracket, because minus half constant is there. So you have to use integration by parts within bracket. Write integration by parts within third bracket. Okay. So log x is the first function. Log x integration of dx minus integration of second bracket dy dx of log x, right? Then integral sign dx, second bracket closed dx, then third bracket is closed. Okay, so this is your integration by parts for the function integration of log x dx. Or now this is I is equal to 1/4 x into log x whole square minus half within third bracket. Now you first integrate. What is integral sign dx? That is your x. So this is your x log x minus integration of, what is dy dx of log x? It is 1 upon x into, what is integral sign dx? That is your x, then dx. Third bracket is closed. Okay, So here you can cancel this, x gets cancelled, that is 1, or I is equal to 1/4 x into log x whole square. So let us multiply by minus half here. So it is minus half x log x, right? So minus into minus plus, this is half integral sine dx. Is that clear? So now you can integrate it. What is integral sine dx? That is x. That is the last integration out here. Okay. So or I is equal to 1/4 x into log x whole square minus half x log x plus half into x plus c. So this is the final answer. So I think I've understood it. Okay. So this is very, very important question. So now you can do it at home. So this is not from the book. Okay. So this is your homework. The question is, you can integrate, that is integration of log x whole square dx. It is same as this problem. Okay. Question number 7. So you can do it at home. That is integration of only log x whole square dx is there. So this is your homework. Okay. You can do it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 8. You have to evaluate this integration, that is integral of log within bracket x square minus 5x plus 6 bracket close dx. So let us evaluate this integration. So let us first write I is equal to integration of log of x square minus 5x plus 6 bracket close dx. So how can you evaluate this integral? So this is also, there is only one function, that is, it is in the form log x form. Here also you have to use integration by parts. Before that, you can factorize the expression, that is x square minus 5x plus 6. You know that this is a quadratic expression. We can factorize it by middle term breaking, isn't it? So let us factorize it. X square minus 5x plus 6, okay? So x square minus 5x plus 6 can be factorized, is equal to x square minus, this is 3 plus 2 into x plus 6. You know how to factorize it. Is equal to x square minus 3x minus into plus minus 2x plus 6, which is equal to, what is common here? X. This is x minus 3 minus 2 common, x minus 3. So it is x minus 3 into x minus 2. Okay. So we have factorized x square minus 5x plus 6. That is, we get x minus 3 into x minus 2. Let us write it here. Or I is equal to integration of log. Let us write it within second bracket. What is within second bracket? X minus 3 into x minus 2. Second bracket closed, then dx. Okay. So what will you do in the next step? Again, you can use the formula log of AB or the properties of logarithm, log of AB. What is the logarithm of the product of two numbers is equal to sum of their logarithms? You know that, isn't it? Which is equal to log A plus log B. So it is log A plus log B. So let us write it here. Or I is equal to integration of, this is log A. Here A is log of x minus 3 plus log of B. What is B? X minus 2. Second bracket closed. Then what do we write? Dx. Okay. So this is log A plus log B. Here A is taken as x minus 3 and B is taken as x minus 2. So this is log A plus log B. So let us separate the term. So I is equal to integration of log of x minus 3 dx plus integration of, this is log of x minus 2 dx. So this is integration of only log x function is there. This is also integration of log of x minus 2 dx. Only logarithm function is there. Here also you have to use integration by parts. You know how to use integration by parts now. So for this both the function you have to use integration by parts. So let us use integration by parts here. So I is equal to, this is the first function, log of x minus 3 comes in the front, comes outside, integration, integral sign dx minus integration of second bracket dy dx of log of x minus 3, right? Integral sign dx, second bracket close dx. So this is integration by parts for the first function. So in the next line, let us use integration by parts for the second function. Okay? So log of x minus 2 comes in the front, log of x minus 2 integral sign dx minus integration of second bracket dy dx of log of x minus 2 integral sign dx second bracket closed dx. Clear? So now let us simplify it now. Or I is equal to, let us first integrate. What is integral sign dx? X. Then log of x minus 3 is kept as it is. Log of x minus 3 is kept as it is minus integral sign. Now it is just like your dy dx or log x form. X minus 3 is taken as x. What is the differentiation of log x? 1 upon x. But here it is 1 upon x minus 3. It is 1 upon x minus 3 into, again differentiate the term which is assumed as x. Here x minus 3 is assumed as x. So what is the differentiation of x minus 3? That is your 1. So into 1 into, what is the integral sign dx? X dx. Okay? So in the next term, what will be the next term now? What will be the next term? Then plus, this is the continuation line, plus, let us first integrate dx, that is your x, then write down log of x minus 2, it is log of x minus 2, then minus integration of, what is dy dx of log of x minus 2? It is just like your log x, 1 by x, so it is 1 upon x minus 2. Here also you have to differentiate the term which is assumed as x. That is, what is the differentiation of x minus 2? It is 1 into, what is integral sign dx? It is x dx. So I hope you have understood it. Okay? So or I is equal to, this is x log of x minus 3 minus integration of, this is your 1 into x dx divided by x minus 3 plus x log of x minus 2 minus integration of 1 into x is x divided by x minus 2 dx. Is that understood? So now this first term and this third term can be simplified. There is x is common. Okay, and now you have to integrate this function and that function. Right, so or I is equal to, from first and third, what is common? X is common. So within bracket we have log of x minus 3 plus log of x minus 2. Second bracket is closed. Is that clear? So minus integration of, now how can you evaluate this x upon x minus 3 dx? Let us simplify it first. I already told you that in this case, the power of x is 1 in the numerator, and in the denominator also the highest power of x is 1. If the highest power of x in both the numerator and the denominator are same, what is the method? Whatever is there in the denominator, you have to write it in the numerator. That is, you write down x minus 3 in the numerator. X minus 3 is written in the numerator. So x is okay. So is there minus 3? No. So you have to write plus 3 divided by what? It is x minus 3, then you write dx. So same method is used for that last integration. Okay. So minus integration of, here also you can use the same method. Let us write x minus 2 in the numerator, but there is only x, no minus 2. So you have to cancel it. Plus 2 divided by x minus 2 dx. Is that understood? Okay. So next, or I is equal to x into, again you can use logarithm, properties of logarithm. Log a plus log b is log of ab. So it is log of, within second bracket, x minus 3 into x minus 2. Second bracket is closed. So let us separate the term out here. Minus integration of x minus 3 upon x minus 3 will be cancelled. That is 1. 1 into dx is dx. Right? So minus 2 plus is minus. 3 is constant. Taken outside. Integration of. This is dx divided by x minus 3. Clear? Next. Similarly, you can separate this term. Minus integral sign x minus 2 divided by x minus 2 will be cancelled. You will get dx. Then minus 2 plus minus 2 is constant, taken outside. Integral sign, this is dx divided by x minus 2. Is that clear? So I think you have understood it. So let us simplify it. Or I is equal to x log of, within bracket. Let us multiply them. X into x is x square minus 2x minus 3x plus 6. Next, minus, what is the integral sign dx? X minus 3. This is log of x minus 3. The base is e. Because here the power of x is 1. So this is not the standard form. Okay. So x minus 3 is taken as x. That is dx by x is log x. So it is log of x minus 3 whole divided by differentiation of x minus 3. That is 1. So since whole divided by 1 is there, so 1 you don't have to write it. Okay. So minus, what is integral sign dx? That is minus x. Then minus 2 log of, this is x minus 2. And what is the base here? Base is e. Then what do you write? Plus c. So I think you have understood it. Okay. So or I is equal to, this is x log of, within bracket, let us simplify it, x square minus 5x plus 6. Okay. Minus x is minus 2x minus 3 log of, within bracket, x minus 3, the base is e. Then minus 2 log, within bracket, x minus 2, the base is e. Then what do you write? Plus c. So this is the final answer. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 9. So let us evaluate this integration. That is integration of x cube log x whole square dx. So let us evaluate this integration. So therefore this is I is equal to integration of x cube log x whole square dx. Okay. So in this case, x cube is algebraic function, that is your a, and log x whole square is your logarithmic function, that is L. So in the word liet or islet, which letter comes first in the word liet or islet? L comes first. So log x whole square is the first function and x cube algebraic function is the second function. So you can use integration by parts here. So the first function, which is log x whole square, is taken outside integration sign. That is your log x whole square. Integration of, this is x cube dx. Okay. Minus integration of, second bracket, dy dx of first function, that is log x whole square. Then integration of x cube dx, second bracket close dx. Clear? Next, or I is equal to, let us first integrate. What is the integration of x cube dx? You can use integration of x to the power n dx, which is equal to x to the power n plus 1 divided by n plus 1. You know that, isn't it? So it is x to the power 4 by 4 into, this is your log x whole square minus integration of, what is d by dx of log x whole square? It is just like your x square. So it is twice log x into, again you have to differentiate the term which is assumed as x. That is, log x is assumed as x. So what is this differentiation? It is 1 upon x into, what is integration of x cube? It is x to the power 4 by 4. Then you can write dx. So I hope you have understood it. Okay. So this is 2 1s are 2, 2 2s are 4, x 1s are x. This is x cube. You can cancel x to the power 5, x to the power 4 by x. So it is x cube. Or I is equal to, this is x to the power 4 by 4, right? Then this is log x whole square. Then minus, here half is constant, it is taken outside. Integration of, this is your x cube log x. Then what do you write? Dx. So it is half is constant, that is taken outside, integral sign, half integration of, this is x cube, then log x dx. So again you have to use integration by parts, because this is integration of the product of two functions are there. Okay, so x cube is algebraic function and log x cube is algebraic function, that is a, and log x is logarithmic function, that is L. Is that clear? So here log x is the first function and x cube is the second function. You know that, isn't it? So let us use by parts here also. So therefore I is equal to, first function is kept as it is, that is x to the power 4 by 4 into log x whole square. Okay, minus half is constant. So you have to use by parts within third bracket, because there is minus half. So you have to use integration by parts within third bracket. So which is the first function? Log x. Log x is the first function, it is taken outside. Integration of x cube dx. This is x cube dx minus integration of second bracket. This is dy dx of log x, right? Then integration of x cube dx, second bracket closed, dx. Then third bracket is closed. So you have used integration by parts for this two function, that is x cube log x. Okay, so or I is equal to, this is x to the power 4 by 4 log x whole square minus half within third bracket. So let us use integration first. What is integration of x cube? You know that this is x to the power 4 by 4 into log x, right? Minus integration of, what is d by dx of log x? It is 1 upon x into, what is integration of x cube? This is x to the power 4 by 4. Then what do we write? We write dx there. Is that clear? So we can cancel here, x 1s are x, it goes x cube times x to the power 4 लाई x ले cancel गर्दा कति भयो? x cube भइगयो. ठीक छ? So or I is equal to, first term is kept as it is, x to the power 4 by 4. This is log x whole square. Now you can open this bracket, multiply by minus half there. So it is minus x to the power 4 by 8 log x, right? Minus into minus plus. This is 1 by 2 into 1 by 4. This is 1 by 8. Then integration of, this is only x cube dx. So this is your last integration, because this is integration of only x cube dx is there. You can easily integrate it, right? Or I is equal to, this is x to the power 4 by 4 log x whole square minus x to the power 4 by 8. This is your log x plus 1 by 8 is constant, it is kept as it is. Now what is integration of x cube? This is x to the power 4 by 4. Then what do you write? Plus c. So or, now let us write down the final answer now. Now what is I? I is equal to x to the power 4 by 4 log x whole square minus x to the power 4 by 8 log x plus x to the power 4 by 32 plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is 10 number 1. Integration of log within bracket x plus root under x square minus a square bracket close dx. Here also only logarithmic function is there. So if there is only logarithmic function, then you have to use integration by parts. So this is the form log x and there is one x to the power 0, that is your algebraic function. So this log x is the first function out here. So let us first write I is equal to, let us integrate it. Integration of log within bracket x plus root over x square minus a square bracket close dx. Okay. So let us use integration by parts. This is the first function. Log x is the first function. One algebraic function is the second function out here. So or I is equal to this log of x plus root over x square minus a square is taken outside. So it is integration of only dx is there. Is that clear? Then comes minus sign. Integration of second bracket. This is your dy dx of log of x plus root over x square minus a square. Right? This is the first function. Then integral sign dx, second bracket closed dx. So this is your integration by parts. So you have understood it. Okay. So or I is equal to, now you first integrate. What is integral sign dx? That is your x log of within bracket x plus root over x square minus a square minus integration of. Now what is dy dx of log of this function? This is just like your log x. What is the differentiation of log x? 1 upon x. So it is 1 upon, what is x here? X plus root over x square minus a square into, again you have to differentiate the term which is assumed as x. Which function is taken as x here? It is x plus root over x square minus a square. Again you have to differentiate this term which is assumed as x. That is, you have to differentiate x plus root over x square minus a square. Okay. So within third bracket, let us write down the differentiation of this function within third bracket. What is the differentiation of x? 1 plus, what is the differentiation of root over x square minus a square? It is just like your root over x. Now this x square minus a square is taken as x. What is the differentiation of root over x? It is 1 upon 2 root over x square minus a square. Clear? Into, again you have to differentiate the term which is assumed as x. That is x square minus a square is assumed as x. So what is this differentiation? For x square it is 2x and for minus a square there is a constant, that is 0. Okay. So here third bracket is closed. Then what do you write? What is integral sign dx? That is your x dx. Is that clear? So here you can cancel this. 2 will be cancelled. Or I is equal to, this is x log of within bracket x plus root over x square minus a square. Okay. Minus integration of, this is your 1 upon x plus root over x square minus a square into, now within third bracket. So what's the LCM here? Root over x square minus a square. So now in the numerator we have root over x square minus a square, then plus. So it is 1 into x is x. Third bracket is closed. Into what do we write? X dx. You have to write down this x dx. Is that clear? So you can cancel here. These similar terms can be cancelled from both the numerator as well as from the denominator. So or I is equal to, this is your x log of x plus root over x square minus a square. Okay, then minus sign is there. Integration of, this is your x dx divided by, in the denominator you have to write root over x square minus a square. Is that clear? So we can write it as I1, or I is equal to x log of, within bracket, x plus root over x square minus a square minus, this is your I1. Okay, so let us write down this integration as I1. So let us evaluate I1 now. Let, what is I1 here? What is I1 in this case? Integration of x dx. Integration of x dx divided by root over, it is x square minus a square. So let us evaluate this integration. How can you evaluate it? If you differentiate the expression under square root, that is x square minus a square, you will get 2x with respect to x, isn't it? So we are getting x in the numerator. 2 is constant, you can manipulate it. And the constant 2 say हामी यताउता मिलाउन सकिहाल्छौं. So let us assume x square minus a square as z square, because x square minus a square, the expression is under square root and it is in the denominator. We can assume this x square minus a square as z square. So let z square is equal to x square minus a square. So let us write differentiating both the sides with respect to x. Okay, what is the differentiation of z square with respect to x? 2z dz by dx is equal to 2x only, because a square is constant, so its differentiation is 0. Okay, so we can cancel this, 2 gets cancels, or let us cross multiply, z dz is equal to x dx. That means, what is the value for x dx? It is z dz. Okay, so let us put it in I1. So I1 is equal to integration of, what is x dx? It is z dz divided by, what is root over z square? X square minus a square is z square. So what is root over z square? It is z. So here you can cancel this, z will be cancelled. Or I1 is equal to, this is integral sign dz, or I1 is equal to, this is z plus c. Integration of dz is z plus c. So what is the value for z now? Or I1 is equal to, what is the value for z? Since z square is equal to x square minus a square, what is the value for z? It is root over x square minus a square plus c. So this is the value for only I1. Okay, so let us put this value for I1 in I to get the answer. So let us put this value for I1 in this I. So therefore I is equal to, what is it? What is the first term? X log, within bracket, x plus, it is root over x square minus a square, bracket closed, right? Minus I1. Minus, what is I1 here? It is root over x square minus a square. It is root over x square minus a square. Then what do we write? Plus c. So this is the final answer. So you can copy it. Now we'll do the next question. So now we will do standard integrals in terms of integration by parts. In integration by parts also, there are three standard integrals. You should know it. So let us write down these three standard integrals and then we will prove it. Okay? The first standard integral is, now let us write standard integrals. Okay? Then we will prove these standard integrals in case of integration by parts. So number one is integration of within square root x square plus a square dx. Sometimes you may get, after simplification, you may get this type of standard integral, that is root over integration of root over x square plus a square dx. So there is a formula. The formula is, which is equal to x root over x square plus a square by 2 plus a square by 2 log within mod. Within mod we have x plus root over x square plus a square, mod sign close, the base is e, then plus c. So this is the first standard integral in integration by parts. You should know it. यसलाई चाहिँ तिमीले याद गर्नै पर्छ यो स्ट्यान्डर्ड इन्टिग्रललाई पनि. Okay? So now number 2 is integration of root over x square minus a square dx is equal to, it is x root over x square minus a square by 2. Instead of plus there is minus, instead of plus there is also minus a square by 2, then it is log within mod. What will you write? You should write x plus root over x square minus a square, mod sign closed, the base is e, then this is plus c. This is the second standard integrals in integration by parts. And the third one is integral sign root over a square minus x square dx. Now within square root, this a square is constant and x square is the variable. Okay? So which is equal to, its formula is x root over a square minus x square by 2. Okay? Then you should write plus in this case, not minus. Plus a square by 2, then you should write sine inverse x upon a, then what do you write? Plus c. This is the third standard integral in integration by parts. So you should know all these three standard integrals in integration by parts. So let us prove this first one now. So you can copy it. So now let us prove this first one, number one. Let us prove it. This first standard integral. So now let us prove it. So therefore I is equal to integration of root over x square plus a square dx. Okay? So this is the only function there, root over x square plus a square dx. So let us use integration by parts in this case. Actually root over x square plus a square is the algebraic function and there is 1. So we can take this as first function. Root over x square plus a square is taken as the first function and 1 is taken as the second function in this case. Don't use late word in this case. Okay? So this is quite different problem out here. In this case also you can use integration by parts, but don't use that word liate or isolate in this case, because root over x square plus a square is the algebraic function and 1 is also algebraic function. But in this particular problem or in this particular standard integral, we can take this root over x square plus a square as the first function and 1 as the second function. So let us use integration by parts in this case. So I is equal to root over x square plus a square is taken outside, integral sign dx. Then comes minus integral sign second bracket. This is dy dx of what? Dy dx of what? Dy dx of root over, this is x square plus a square. That is your first function. Then integral sign dx, second bracket closed, dx. That is, this function is integrated by parts. Okay? Or I is equal to, what is integral sign dx? This is x root over x square plus a square minus integration of, what is dy dx of root over x square plus a square? What is that? What is integral sign dy dx of root over x square plus a square? It is, this is just like your root over x. Root over x. What is the differentiation of root x? 1 by 2 root x, but here it is 2 root over x square plus a square, right? Into, again differentiate the term which is assumed as x. In this case, x square plus a square is assumed as x. What is this differentiation? It is 2x into, what do we write? Integral sign dx is x. Then dx. Okay? So here 2 gets cancels. Or I is equal to, now this is x root over x square plus a square minus integral sign x into x is x square, then dx divided by root over, this is your x square plus a square. So I think you have understood it. Okay? So now what will you do in the next step? Now in the numerator, what is the highest power of x? That is 2. And in the denominator within square root also, and in the denominator within square root, the power of x is also 2. So whatever is there in the denominator within square root, write it in the numerator. Okay? So or I is equal to, this is x root over x square plus a square minus integral sign, whatever is there in the denominator within square root, write it in the numerator. That is, you have to write x square plus a square in the numerator. X square plus a square is written in the numerator. So we have got x square, but there is no a square here. You have to cancel it. So what do we write? Minus a square divided by, it is root over x square plus a square, then what do you write? Dx. Is that clear? So now we can separate the term here. Or I is equal to x root over x square plus a square minus integration of, let us separate it, x square plus a square divided by root over x square plus a square. And minus into minus is plus, a square is constant, taken outside, integral sign dx divided by root over, this is your x square plus a square. Clear? Now we can cancel here. You root over le mathi body kati times answer? Root over x square plus a square. You know how to cancel it, isn't it? So here also you have to write down dx. Here also you have to write down dx. Okay? So or I is equal to, this is your x root over x square plus a square minus integration of, this is your root over x square plus a square dx. Then this is your plus a square into, now this is the standard integral from the method of substitution. That is integral sign dx divided by root over x square plus a square. That is your standard integral from method of substitution, and you should know this standard integral. What is the formula? It is log within mod x plus root over x square plus a square plus c. The base is e. So I think I've understood it. Okay? Or I is equal to x root over x square plus a square minus. So what will you do with this integration? Again, there is integration of root over x square plus a square dx is there, but this is this one, isn't it? That is integral sign root over x square plus a square dx is also here. Here we have got this root over x square plus a square dx. Same integration is there, but you can write it as I. So you can write it as I, because it is assumed as I. So you can write, instead of integral sign, root over x square plus a square dx as I. Then what do you write? Plus a square log within mod x plus root over x square plus a square mod sign close, the base is e, then plus c. Okay. So now minus I, take it to the left hand side, because you have to get the value for I. So minus I is taken to the left hand side. What do we get? I plus I is 2i is equal to x root over x square plus a square plus a square log within mod x plus root over x square plus a square mod sign close, the base is e. Then what do we write? Plus c. So let us get the value for I now. Or now this is I is equal to, what do we write? This 2 is taken to the right hand side. You can write it in the denominator. In each and every term, you can write it in the denominator. Okay. So it is x by 2 root over x square plus a square plus, this is also a square by 2 log within mod x plus root over x square plus a square mod sign close, the base is e, plus c by 2 is there. But what is c by 2? That is your c, because c is also constant, 2 is also constant. You don't have to write c by 2, but you can write it as plus c. So it is proved. So you have to remember this formula. That is your first standard integral. Okay. Now you can prove that second standard integral. So the proof of second standard integral for this integration by parts is your homework. Okay. So you can prove that number 2 at home. So let's do proof of number 3. So you can copy it first. Now that is number 2 is standard integral. You have to prove standard integral number 2 at home. That is your homework. Now let us prove this standard integral number 3. That is integral sign root over a square minus a square dx is equal to, you have to prove x root under a square minus a square x root under a square minus a square by 2 plus a square by 2 sine inverse x upon a plus c. So let us prove it. So I is equal to integration of root over a square minus x square dx. So here also you can use integration by parts as we have done in standard integral number 1. So this is the first function here also. Let us take it outside. So this is your root over a square minus x square is taken outside, integral sine dx minus integration of second bracket dy dx of root over a square minus x square integral sine dx second bracket close dx. Okay. Now this is integration by parts, and this root over a square minus x square is taken as the first function and 1 is taken as the second function. Okay. But in this case, liet or eyelet word are not used out here. Okay. So or I is equal to, what is integral sine dx? X root over a square minus x square minus integration of, again, what is dy dx of root over? It is 1 by 2 root over x, 1 upon 2 root over, this is a square minus x square into, now again differentiate a square minus x square, that is your minus 2x. Okay, into, what is integral sine dx? That is your x dx. So here 2 gets cancels, or I is equal to x root over a square minus x square, right? Then you have to write minus integration of, this is minus x square divided by root over a square minus x square, then what do we write? Dx. So let us keep it as it is. Don't multiply this minus sign plus, don't write it. Okay, because before x square there is minus, So here also x square, before this x square there is minus sign. So don't cancel it. Don't write minus into minus as plus. Okay. So in the numerator the highest power of x is 2, and in the denominator also the highest power of x is 2. So whatever is there in the denominator within square root, write it in the numerator. Okay. So or I is equal to, this is your x root over a square minus x square minus integration of, let us write here a square, minus is already there, minus x square is there. So minus x square is okay out here, it's correct, but there is again a square. But is there a square here? No, you have to cancel it. So minus a square divided by root over a square minus x square, then what do you write? Dx. So now what will you do in the next step? You can separate the term now. Or I is equal to, this is x root over a square minus x square. So let us separate this integration. Minus integral sign. So how can we separate it? It is a square minus x square dx divided by, what is there in the denominator? It is root over a square minus x square. Is that clear? Then minus into minus plus, you have to multiply it. Minus into minus plus. Plus a square is constant, integral sign. What do we write? A square is constant, that's why it is taken outside, integral sign. Then you have to write dx divided by root over a square minus x square. So it is dx divided by root over a square minus x square. So I think you have understood it. Okay. So here you can cancel this, root over a square minus x square times. Okay. So or I is equal to, this is your x root over a square minus x square minus integration of root over a square minus x square dx plus a square into, now this is the standard integral from method of substitution. That is your sixth standard integral. So what is the integral sign? Dx divided by root over a square minus x square. It is sine inverse x upon a, then you have to write plus c. Or I is equal to, this is x root over a square minus x square minus. So what will you do with this integration? What will you do with this integration? That is integration of root over a square minus x square dx. Actually it is taken as I, isn't it? That is integration of root over a square minus x square dx, it is taken as I. So instead of this integration you can write down I. So it is minus I plus a square, this is your sine inverse x upon a plus c. So minus I is taken to the left hand side. So I plus I is 2i is equal to x root over a square minus x square plus a square, this is your sine inverse x upon a plus c. So what is the value for only I? Because you have to get the value for I, isn't it? So I is equal to x root over a square minus x square by 2 plus a square by 2. 2 is taken to the right hand side, it goes to the denominator side. Okay. So it is sine inverse x upon a plus, actually it is c by 2, but here c is constant, 2 is also constant. So c by 2 is constant, you can write it as c. So it is proved. So this formula number 3, standard integral number 3 is very, very important. Okay. Similarly you can prove that standard integral number 2. So I think you have understood this number 1 and number 3. The similar method may be used in order to prove that standard integral number 2. So you can do it at home. Okay. So this much is for today. त आज हामीले जति पनि प्रब्लम्सहरु गरेका छौं हैन, सबै तिमीले घरमा राम्रोसँग रिभिजन गर्नु, यसलाई रिभिजन गरेर फेरि तिमीले घरमा प्र्याक्टिस गर्नु सक्छौ। अनि मैले अझ एउटा होमवर्क दिएको थिए, दैट इज इंटीग्रेशन अफ log x होल स्क्वायर dx, दैट यू क्यान डु इट एट होम। अनि एउटा स्ट्यान्डर्ड इंटीग्रल नम्बर 2 तिमीले घरमा प्रुभ गर्न सक्छौ। So this much is for today. In the next online class we'll do more problems on this integration by parts. तो यो तीनटा फर्मुला पनि तिमीले घरमा एकदमै राम्रोसँग पढ्ने, याद गर्ने। ठीक छ, these are the three standard integrals in integration by parts. Okay.